Hello, it's Scott Manley here. GPS is everywhere and it's used in many things. I carry multiple devices with me that all have GPS receivers, such as my phone. My car has it built in. My plane has 3 different GPS receivers. What was once a specialized military technology has become so commonplace it is now a part of the fabric of everyday life. And let's be clear, GPS is not the only game in town. There's GLONASS, Beidou, Galileo. They all perform the same function, and you generally refer to them as Global Navigation Satellite Systems, or GNSS. And thanks to these technologies, it's almost impossible for someone to get lost these days. Aircraft used to rely on ground-based navigation systems, but these days everyone has GPS-based area navigation. The only instrument approach at my local airfield is an RNAV GPS approach, which doesn't use any ground-based navigation systems at all. In fact, in the US, the number of ground-based navigation aids has been slowly decreasing as GPS begins to dominate all the aviation navigation needs. And ground facilities are breaking down, and without an obvious reason to replace them, they are going unrepaired. And it's not just used for navigation. Increasingly complicated aircraft avionics are incorporating GPS data with other sensors to provide other information. My aircraft, the Compass, is also a directional gyro, which is, driven by GPS information. I've seen angle of attack indicators which rely on GPS information. Systems that measure wind speed are also using this. So if there was a problem with GPS, it isn't just that you're going to lose your way, you might lose basic instrumentation in your aircraft if it relies on that. But a couple of weeks ago, Finnair had to cancel their newly opened route to Tartu in Estonia because GPS jamming was making it impossible to navigate reliably. Now, they didn't say who was responsible, but open source intelligence analysts know exactly where this is coming from because we actually have a way of tracking GPS glitches. Aircraft, when they're flying, they broadcast ADS-B, which is basically a signal that says their GPS location over time, and they keep broadcasting this. And where it goes wonky, you can say that this is possibly because of GPS interference or jamming. So now if you plot the points where you have this interference kicking in, and then you assume that they have to be able to see the target on the ground, or the source of the interference on the ground, you can draw rings around this and see that the whole thing ends up centering on a point just inside Russia, southwest of St. Petersburg. And that's one of them. But there's another Baltic jammer which has been involved in recent months, and that is been traced to a region called Kaliningrad. Now, Kaliningrad is a bit of a territorial oddity. It's part of the Russian Federation, but it's not actually connected directly. It's on the Baltic coast between Poland and Lithuania, and it's Russia's only ice-free port in the Baltic, so it's kind of important to them. It used to be known as Kongsberg because it was part of Germany. It was their easternmost city right up until World War II. Afterwards, it became part of the Soviet Union. It was renamed Kaliningrad in honor of Mikhail Kalinin, who was like a early leader, party official, and he lived in the city, I think, when he died. And yeah, this name has become a little problematic in recent years because they're right next to Poland, and Mikhail Kalinin was one of like 6 leaders that signed an order to basically execute thousands of Polish prisoners of war in a war crime known as the Katyn massacre, which has the dubious distinction of being a war crime reported publicly by the Nazis. Yeah, the history of this region is complicated. So anyway, yeah, it's been known for a long time that there's GPS jamming and interference coming from inside Russia. It's also around Ukraine, obviously, a war which has seen a huge number of drones being used, many of which are relying on consumer-grade GPS hardware. So it makes complete sense to deploy GPS interference to basically blunt these technologies' effectiveness. Now, the ITU specifically prohibits GNSS interference, and it's easy to say that Russia is breaking those rules, those international laws, but okay, let's be clear, we all know that most other nations have similar capabilities. It's not exactly difficult to figure out how to jam GPS. I even pointed out that in a previous video that the US designed GPS system has differences between the military and the civilian signals that make it easier for the jamming of the civilian signal while leaving the military signal available. So, this is not something that hasn't been thought of. And we also get what are called GPS NOTAMs, which will tell pilots, by the way, if you're near this test range, you might have some GPS interference, so, don't necessarily trust it. Elsewhere around the world, there's been a few other stories, and one of the more spectacular ones, I think, is these viral videos of drone shows in China, where the drones are supposed to be spelling out some ad, and they just start falling out of the sky. And this has actually been accompanied by stories that this is because of a rival advertising company jamming the drones to try to make their competitors look bad. I'm not sure I believe this, but we do know that there is actually a lot of GPS jamming in and around China, so it's not something that doesn't happen. Beyond simply like losing navigation signal, there's other things that can go wrong. For example, cell phone networks, all those cell towers, frequently they will use GPS signals to get their time so they can synchronize their clocks across the network. And when those things get out of sync or they can't get signals, it's entirely possible that you lose cell phone signal, even although there isn't, say, they aren't relying on a satellite signal to transmit the data around. So yeah, you can find cell phones not working or cars losing their location or all sorts of other problems. But yeah, look, to jam GPS, it doesn't take a massive amount of technology, right? The satellites are tens of thousands of miles away. The signals are very, very weak. And you could actually accidentally jam GPS signals just in everyday work. There's like certain frequencies if you tune your nav radio, and there are harmonics of that will happen to coincide with the GPS frequency. And there's been cases where pilots literally, they hit the push to talk button to transmit and they find their GPS system stopping working while they're transmitting because of some far-fetched harmonic that just happens to overpower the GPS signal. There's other things like this where it doesn't take a lot of power. Like, it only takes a few watts of power on the ground to transmit a signal which can obliterate the GPS signal for miles around because it's very, very weak. Now, as you can imagine, the way jamming works is you put out a radio signal in roughly the same band with lots of noise and energy, and you swamp the signal that is being looked for so that it isn't recoverable. It's like you're talking across the street to your neighbor or your friend, and a car rolls up between the middle of you, pumping its stereo loud, revving its engine. You can't hear what they're saying until they slam the accelerator or screech off into the distance and you can hear them again. Now, GPS is already designed to deal with very high levels of noise, very weak signals. Like the CDMA encoding that it uses repeats the same bit millions of times, maybe lots and lots of times, so that it can be pulled out of the noise. It's like transmitting 50 bits per second over a frequency of 1.5 gigahertz. There's a lot of bandwidth there, and so they can get this very low bit rate signal through at very low signal powers. But even then, there's a limit to how much noise before it drops in. And also because of the way GPS works, the way CDMA works actually, it's harder to get the initial lock on the signal, but once you've got a lock on, it's a lot easier to maintain it. So you could get into a situation where you have like a system that's just starting up isn't able to get any GPS signal, but a system that's been running for a while, when the jamming starts, it's able to maintain the lock. So, you can get some disparity in performance between those. Anyway, back to Kaliningrad, amateur radio operators have actually captured the interference. We've got nice waterfall plots from the area. And what they're using is pretty broad stuff. Sometimes it's targeting certain frequencies, sometimes it's targeting GPS and other GNSS systems. The spectrum is actually changing over time by the looks of things, as if they're experimenting with different concepts. But it also appears that it's not omnidirectional. That is, that they've got cutouts where they're not broadcasting, or at least it's broadcasting at a lower level. And I would imagine that this is so you can have friendly aircraft navigate in, because after all, Kaliningrad is disconnected from the rest of Russia, and one way to get in and out is via an aircraft. And it would be a shame if they couldn't land. But anyway, yeah, GPS jamming is easy. You can do it accidentally. It's really easy to build hardware to do it. It's not legal, but it's very easy to do. It's also very easy to figure out where such a signal would be coming from. A far more interesting attack is GPS spoofing, and that is where you generate false GPS signals and try to convince the target that they're somewhere where they're not. And this is a vastly more sophisticated attack, right? Most GPS hardware implementations are pretty trusting, and they will happily lock on to the strongest signals they can get and use those instead of the real satellites. But GPS spoofing is still very complicated. It's not something that can be used indiscriminately over a wide area with a signal transmitter. GPS, of course, works by measuring the timing of signals from satellites, and the satellite's position has to be determined from orbital elements which are published inside this signal. It's conceivable that a spoofing attack might simply replace the orbital elements in the signal or the timing code, or perhaps it could attack the differential GPS signal used for like WAAS GPS, saying that the correction is sufficiently far. And, maybe you can only change the location on a differential attack by, tens of meters. But guess what? Tens of meters is sometimes far enough if you're dealing with munitions that are supposed to hit a target with great precision. But anyway, there are multiple ways that an attack could proceed. But yeah, say you wanted to spoof a specific satellite, you could just start broadcasting a matching signal, perhaps making it a bit stronger, and hope that receivers will lock onto it. And ideally, you do it with a whole bunch of simulated satellites. You just replicate the entire network so that you have complete control of the new signal. And then a receiver might lock onto your signal and think that they're at the location that you specify. One problem, though, with this is if you're broadcasting from a single site, then the relative timings aren't going to change. So one of the important parts of GPS is the timings between the various various satellites changes depending upon location, so you can figure out your location. But if you're coming from a single site, you can't really do that. So at best, if you broadcast a spoofing attack from a single antenna, everybody ends up thinking they're in the same place, and there may be some utility to that, but if you're really going to tailor your attack to specific targets, you have to hit that target with a narrow, focused radio beam and give them, all of your attention. You might have multiple beams, but the point is you're aiming at one target and tailoring the signal specifically to them, and this might need a fairly large antenna to make it focused enough. So, look, if you start sending fake signals to something that's ready in flight, what's going to happen is it may have the existing satellites tracked. You're now going to get new satellites coming in, and these positions are going to be inconsistent, and you're going to end up with a confused GPS receiver unless you specifically tailor your signal to remove those other satellites from the system. And one way you could do this is, since you know where the target is, know what it should be receiving because you know the state of the GPS system, you can then transmit the opposite signal, cancel out as much of the real signal as possible, and then on top of that you transmit your fake signal, again targeting one specific object, and then you slowly, starting at the same state, you can then evolve it away. That is absolutely theoretically possible. And if you did do that, you could start sending, different flight tracks. Take a consumer drone. I flew my Mavic a while back, and the amazing thing about it was when you would have it take off and you would just leave it hanging there, and it would just remain solid, hanging motionless in the air in exactly the way bricks don't, right? Yeah, we know where that comes from, right? But now imagine it's getting GPS information and it's at sufficiently high altitude that it's no longer using its ground tracking cameras. Well, imagine a spoofed GPS signal started telling it was moving. Well, it might want to correct in the opposite direction. And by doing that, it would fly. So you could slowly make it fly around. And this has actually been demonstrated by researchers. They put a drone in like in a RF insulated facility. They had it fly up and hover, and then they started feeding it, spoofed GPS signals and told it to hover still. And they could actually fly it around using a joystick, and the joystick wasn't controlling the drone, it was just sending slightly different positional information to it, and the drone was doing its best to stay still, or so it thought. This is absolutely possible. The reason, of course, you do it inside an RF sealed area is because you don't want those signals getting out to the world, and equally it helps to not have signals from the real satellites coming in and confusing it. Okay, so we know these attacks are possible. How can you defend against them? Well, one really simple way is to have a directional antenna which attenuates signals from below. Satellites are in space. Why should you trust anything coming from on the ground? Now, I found this image of a Russian large drone, and I sort of joked, oh, it looks like they've got the GPS antenna surrounded by these shielding rings, and I was feeling really smart until some antenna engineer said, oh, actually, that's a specific kind of antenna that actually these baffles work together, and they make it just very directional. So it can, in fact, see the sky with a great, quality, but below it, it has something like 30 decibels of signal attenuation. So that helps. That's one way of doing it. But then again, maybe you have somebody that's performing jamming or interference from an aircraft or even a satellite in orbit. There's nothing to say that you couldn't have bad, GNSS signals coming from a hostile satellite. Other things you could do, you can build smarter antenna. You can make multiple antenna that combine the signals with different phases. And by doing that, you give it a directionality. So you can recover the signal, or you can use a directionality which is peculiar to each of the satellites you're tracking, making sure that it's focusing on where the satellite should be rather than where the satellite says it should be. And by doing that, you could effectively eliminate spoofed satellites. Or if you think that a particular satellite or source is bad, you can make a hole in your antenna that just refuses to receive from that direction. I saw one product which was a fancy upgrade to military drones that would do this, and it was literally a box that was its own GPS receiver with a very smart antenna, and it just was sort of velcroed on top of the existing drone. It didn't connect, it just broadcast its own GPS signal into the drone that was like the cleaned up version after all its error detection. Robust GPS, yeah, you could also just detect the stuff that is inconsistent, detect the imposter satellites, and just say, for example, if a satellite signal is too powerful to be from a satellite tens of thousands of miles away, you might flag it as suspicious and start ignoring it. So that way you can't simply spoof something by broadcasting a more powerful signal. But of course, there are in turn counter measures where you can increase the sophistication of your attack and deploy it from other sources and getting around this. And of course, all this time, I've been talking about GPS like it is a monolithic system, but as you probably know, there are actually multiple systems. Like there's the L1 course GPS, and then there's the L2 military, there's like the L5. There's different signals on different frequency bands with different levels of encryption and spoofing checks and different technology. So there is already security being built into modern GPS and, of course, the other competing satellite systems. Ultimately, GPS at the consumer level trusts things perhaps a lot more than it should, which is fine for everyday life. It doesn't necessarily work once you start getting into conflicts. And it's entirely possible to harden a GPS system against jamming with things like directional antennas and limit spoofing by having better complex cross-validation between the data. And obviously a number of these things are already involved and implemented on military hardware. But the airliners, on the other hand, they tend to be a bit more slow moving. It took a long time for GPS to get accepted at the level that it is in airliners. And I suspect that if we had new, secure, spoofing resistant GPS signals or systems available tomorrow, it would still take more than a decade for them to be commonplace in airliners as we speak. So what I'm going to say is to prospective pilots, just learn to read maps. I mean, I love looking at a good old-fashioned map and seeing things on the ground. I'm Scott Manley. Fly safe.